What's up, guys? Welcome to day 17 of May 2020 LeetCode challenge. So today's problem is find all the anagrams in a string. So the problem statement is, given a string S and a non-empty string P, find all the start indices of P's anagrams in S. String consists of lowercase English characters only, and the length of both strings S and P will not be larger than 2010. Well, that's a large number. The order of output does not matter. Alright. So we're given, for example, these two strings. So P is what we're interested in to finding out anagrams of in S. The anagrams of P would include ABC, then ACB, then BAC, BCA, CBA. So let's quickly just go here. CBA is an anagram of ABC, so the starting index is what we're interested in. Yeah, we're interested in this starting index. Find all the start indices of P's anagrams. So CBA starts at 0th index. We input 0 into the output array. Next, we scan through S and we find that BAC, which is an anagram of ABC, is at index 0, 1, 2, 3, 4, 5, and that's 6. So 6th index. If we look here for the explanation, the substring start index 0 is CBA, which is an anagram of ABC, as we've seen, and similarly BAC, which starts here, is also an anagram of ABC. Let's look at the other example. So AB is, we were already given AB, which is an anagram obviously. Next is BA, which is an anagram, so we store 0, 1, and again AB, so 2 again goes into the output, as we can see from here. Right, so there is one consideration that they ask us to focus on, that there are only lowercase English characters that we need to deal with, and the number here would be 20100, which is quite a large number, and if we were to generally sort, that would make our algorithm a little inefficient because we would have to keep on sorting. So if we had to check these three, we sort, we keep and sort P, for example. Let's look here. So we have P, which we sort and store. Then we go through each index of S and substring of length I2 I plus P dot length and sort. So that's 2x sorting there, which makes it really slow, and we would have to keep sorting this for every element in string S. There is another way around this, which is basically having a character array of 26 characters, since it says only lowercase English characters. Thus forth, we can start here with, so let's hold n p dot length. Now all the characters in P is equal to new int 26, and similarly in scars would be new int 26. So what this means is we're going to be holding all the characters from letter A through letter Z in lowercase, and as and when we're going to be encountering one of these letters in string P or S, we're going to basically increment that index. So how do we do that? Let's have a look at P. I is less than n, which is the length of n, I plus plus. Now basically what we're going to do is p chars p dot char at I. So p dot char at I, say for example it was character B. If we subtract a from it, it's going to give us a 0 based index. So b minus a is 1, and similarly a minus a would be 0. So we would basically be incrementing the value of the character which is held at that index each time we encounter it. So that this is how we're going to do it. Next, what we're going to do is we will simply go through S, and here let's hold the instance to the character at I. Now we need to check for if I is greater than or is equal to n. In this sort of a scenario, what will happen is if I has gone beyond the length of p, we would basically want to decrement the value which was held at index I minus n. So how do we do that? We will do s chars c minus a minus minus. I did forget something. It's not c minus a, it's going to be I minus n, which is char s dot char at. So what this basically is going to do is it's going to get us the character which was at I minus n, and once we subtract, we get the 0th index here, 0 based index here for this character, and we're basically decrementing its value so that we don't, it's not counted in the array anymore once we're going to be comparing it later. So now I mean we're already holding it as chars c minus a plus plus. So as here we're going to be incrementing the value for the character which is at ith index. Now all we need to do is check for arrays dot equals. So basically character, the s chars and the p chars array which holds the counts are equal. If that is true, we will have to, so we don't have return so in result we're going to append result with I. So basically what we're doing here is checking if S cache is currently anagram of P. How do we do that? If it's an anagram of P, it will hold the same number of characters which we've incremented here by the count. We're holding counts for each of the characters in the English alphabet. In English alphabets, the lowercase characters. If their counts, that is, all the values that are held at various indices, starting from 0 to 25, so length is 26. If that's equal, then we basically add this. So this method here that we've followed of incrementing and decrementing these values, and here what it does is it removes the overhead of and the need to sort the strings, so, and it makes it a little more efficient than sorting. So now all we basically have to do is return result, and let's just quickly run it once. Oh, we have a compiler error, right? So where is this? Here. Try it again. Okay, so what did we do here is s.cat at I minus n a s cars c minus I. Oh yes, so the result is basically going to be this, the ith index minus n plus 1. So what will happen here is, so what had happened here essentially earlier is that we were holding the value of I only, but with what we've added here, what it is going to do is it will go back to the starting position. So for example here I was 2, and you subtract the length, which is 3, so that becomes minus 1, and if you add plus 1, that is 0. So this value should have been 0 as it says here, and similarly this value should have been 6, which we can calculate easily from here. So the current index minus length of P and plus 1, which will give us the current index or the starting index of the current anagram that we've just encountered. So let's run it to see if it's correct. And it's correct. Let's submit. Awesome, and it's accepted. So just quickly going through the details, we've passed 36 of 36 cases, runtime is 14 ms. We are in the 53rd percentile, which is not bad. Right, thank you guys for watching the video. Do hit the subscribe button and the bell icon, and I'd really appreciate if you would give this video a thumbs up if you like the video. Thank you guys for watching.